What if we like?
All right. So today really isn't going to have anything to do with this chapter in geometry. I need to review some basic Algebra 1 stuff before we can get into how this is going to tie into geometry. So today and probably tomorrow, to be honest with you, I do not believe I'm going to finish the lesson. So today and tomorrow, we are going to review these Algebra 1 topics. So the first one is slope. Can someone tell me, when we're talking about the slope of a line, what are we talking about? The line, it's what? What it is? No.
Rise over run.
Good. The rise over run, which tells us what? What the line is.
Deep.
How steep the line is. Okay. Slope tells us how steep a line is. So the slope is the measure of steepness of a line. And Katie told us that slope, and do we all remember that slope is represented by a lowercase m? Hey, so slope is represented by rise over run when we're given a graph. So you will be happy to know that there are no proofs in this Unit 3B.
Oh, God.
No proofs in Unit 3B. We'll go back to proofs in Unit 4. Okay, so now if we want to talk about the slope of a line, what I do, given a graph, I go to the furthest point on the left. Here's my furthest point on the left, and then I pick a point on the right. So those are my 2 points. All right, so I will go to these points. Now, to figure out the slope, it is rise over run. So to get from one point to the other, I am rising 1, 2, 3, 4 units. Since I'm going up 4 units, is that a positive 4 or a negative 4? Positive 4. And then I'm running to the right. 1, 2, 3, 4, 5, 6. Since I went to the right, do you think that's a positive 6 or a negative 6? Positive 6. So my slope, lowercase m, which is represented by rise over run, for this line will be my rise is 4, my run is 6. But because slope is represented like a fraction, what must you do to all fractions? Simplify. So my slope is 2/3. Now let's say you went the other way, okay? Let's say you started on this blue point and you ended at the green point. That's fine. To get from the blue point to the green point, you're now going up. You're going down. 1, 2, 3, 4. Oh, we went down 4, right? But since you're going down 4, not up 4, down 4, do you think that's positive 4 or negative 4? Negative 4. And then you're going to the left. 1, 2, 3, 4, 5, 6. Since you're going to the left 6, do you think that's a positive 6 or a negative 6? Negative 6. So once again, your slope is going to be your rise, which is negative 4, and your run, which is negative 6. Well, what is a negative divided by a negative? So then your positive 4 over 6, which simplifies down to 2/3. Did we get the same answer both ways? Yes. Lexi, you okay? All right. Any other questions? Any questions on this? So you all try letter B then. If you're good on letter A, try letter B by yourself. All right, tell me, what did you get for letter B? Allie. Got -2. Good. Anybody want to see me do that? Well, anyway, I'm going to do it regardless. All right, so I'm starting at the green, ending at the green, at the other green. So now I'm going from one point to the other point. I'm going down 1, 2, 3, 4. Since I'm going down 4, is that a +4 or -4? -4, and then I'm going to the right 1, 2. So my slope is -4/2, which simplifies down to -2. Very good. Yes.
I did rise from the bottom dot up to the.
Sure. So you went up 1, 2, 3, 4, and then you went to the left 1, 2. So then you got 4/-2, which is still -2. That's perfect. So the first slope was 2/3. The second slope is -2. Okay, does anybody remember how we find the slope given 2 points? Jake?
Y equals mx plus b.
Ooh, that's an equation of a line. We're getting to that next. So I want you to remember that. That's a good one to remember, but that's for a line. Thomas?
Y2 minus y1 over x2 minus x.
Good. If we're not given a graph and we're given 2 points, the slope is found by doing y2 minus y1 over x2 minus x1. And how do we know what's x2, y1, all that good stuff? Well, you go to the points and you assign them names. So the first point is going to be x1, y1. And the second point, guess what that's going to be? x2, y2. You got it. All right, now we're going to substitute into our equation. So it says y2. Well, what number goes with y2? -4. Minus y1, which is? Good. So this is -4 minus -5. Do not just write -4 minus 5. It's -4 minus -5. All right, then we have x2. Do we all agree that's 6? Minus x1, which is 1. What is a double negative happen? What happens with a double negative? Positive. So this ends up becoming -4 plus 5 over 6 minus 1. -4 plus 5 is 1. 6 minus 1 is 5. So the slope is 1/5. All right, we want to highlight this slope formula because we're going to be using it quite a bit in this chapter. What's up, Thomas?
So, why isn't it just y1 minus y2?
You could do that.
Any point.
You can do that. So if you did y1 minus y2, then you'd have to do x1 minus x2. As long as you stay consistent, that's absolutely fine. All right, so now we're going to talk about lines. And Jake told us an equation of a line is represented by y equals mx plus b. This is the equation of a line that we're generally used to seeing. Now, in the equation y equals mx plus b, who remembers what that lowercase m represents? Rach? Slope. Who remembers what the lowercase b represents? Not the y-axis, but you're close. The y-intercept. You got it. So we remember that m is slope, b is y-intercept. Can someone tell me, what do x and y represent? What do x and y represent? So m is the slope, b is the y-intercept. X and y represent something. Mia? Exactly. How many points are on a line? Allie? I'm sorry? Uh-huh. Infinite. There's an infinite amount of points on the line. X and Y represent every combination of possible points that can exist on that line. That's what X and Y represent. Every combination of possible points that can exist on that line. Okay, so now when we want to graph an equation of a line, we want to make sure before we try to graph it that it looks like y equals mx plus b. How do we make it look like that? We need to get y all by itself. So when I give you 2y over 3x, does that look like y equals mx plus b? No, we need to get y by itself. How do we get y by itself? Divide by 2, you got it. So this is going to become y equals 3 halves x. Now, I want it to be y equals mx plus b. What am I missing? What am I missing? Bryce? The b. So I need to put a b. So this is plus what if nothing's there? 0. Good, Jake. That's a plus 0. So y equals 3 halves x plus 0. Now, when you come to graph this, what you want to do is you want to start at your y-intercept. What number is our y-intercept? 0, right? Our y-intercept is 0. So I'm going to go to the graph, and I'm going to go to where it's 0 on the y-axis. Where is it 0 on the y-axis? The origin. So I'm starting there. That's my starting point. So you start at the y-intercept. Then from there, you're going to rise and run according to the slope. So our slope was 3 over 2. That means we're going to rise 3 and run 2. Do we all agree? If our slope is 3 over 2, we're going to rise 3, run 2. So now you go to your point. You go to your y-intercept. And from that y-intercept, I'm going to rise 3. That means go up 3. 1, 2, 3. And then I'm going to run 2. Is 2 positive or negative? Positive, so I'm going to go to the right 2. So I went up 3 to the right 2, and that's my new point. Is there room to go up 3 and right 2 again? No, so now I need to fill in the other side of the line. How do I fill in the other side of the line? So I went up 3 to the right 2, but now I need to reverse this. Bryce?
Down 3 to the left.
You got it. Now we're going to go down 3 to the left 2. And now I'm going to connect it with a line. Does my line need arrows? Yes. Why does the line need arrows? Jake?
It's infinite and it keeps going on.
Yeah, because we need to show that the line goes on forever. Why is this line not working out for me today? All right, I'm just going to freehand this. Line tool's not working out for me.
I tried to do a line and it didn't fit like a perfect line.
Yeah, I don't know why mine's not. It keeps going off. 1, 2, 3, 1, 2, 2, 3, 1, 2. Okay, that's good. Okay, so now we need to graph the other line. So now the other line is negative 6x plus 4y equals 8. Can I graph it when it's in this format? No, what do I need to do? Brenda? Get the y by itself. So the first thing I'm going to do is add the 6x over. So we have 4y equals positive 6x plus 8. Did I have to put that x in the front? Yeah, I had to put the x in the front because I want y equals mx plus b, right? I want the x in the front. Now what should I do? Ollie? Divide everything by 4. Now, does 4 go into 6 evenly? No, but I can simplify that. What can I reduce that down to? 3 over 2x. Good. Plus 8 divided by 4 is 2. So now when I come to graph this line, where am I starting when I come to graph this line? Where do I want to start? 2 where? 2 where?
Positive 2 on the right.
On the right? What is the 2 called? Not the x-intercept, it's called the y-intercept. So I'm not starting 2 on the right. Where am I starting? 2? 2 up, exactly. I'm starting 2 on the y-axis. And then from there, I'm going to use my slope. What is my slope? 3 over 2. We're going to rise 3 and we're going to run 2. So what are we going to do? 1, 2, 3 over 2 to the right 2, and then down 1, 2, 3 left 2. Can I get another point in there? Yeah, 1, 2, 3 left 2. There we go. That one worked for me. Jake? Yes. Okay, first, yes, Ollie.
What happens if like it's like the rise number one is like let's say it started on 2, then the rise number one is like 4 over 2.
And then there was no room.
Yeah.
Then you just have to go down. Like you couldn't go up, just go down. Do the opposite. All right, do these lines intersect? No, what are they? What's their relationship to each other? Perpendicular means they make right angles. Parallel, good. No, they are parallel. Did you notice anything about their slopes? Did you notice anything about their slopes? Katie?
They're the same.
They're the same. What do you notice about the slopes of these lines? Same slope. I want somebody to make a conclusion for me about lines that have the same slopes. Lines that have the same slopes, Rachel, will never intersect, which means they are parallel. If 2 lines have the same slope, those lines must be parallel. So let's write that in here. 2 lines are parallel if they never intersect. The slopes of these lines are the same. The symbol for parallel looks like an 11. Okay, can you guys go and graph number 4 for me? Go ahead and graph number 4 by yourself. First, put it in slope-intercept form in the right format, and then graph it. And we will go over it. Yes, ma'am. I wouldn't divide by a fraction. Why? You know you want to get y by itself, right? Does that help you? Okay. So just so you all know before you start graphing, that is a negative half. So when you change this, this should be y equals, I assign the negative to the numerator only, negative 1 over 2x plus 2. Right? So when you graph, or when you have a negative fraction, you either assign it just to the numerator or just to the denominator. You can't assign it to both, because what is a negative divided by a negative? Positive, so that changes the whole value of the fraction. So you either just assign it to the numerator or just the denominator. I always just assign it to the numerator. Yes.
In the second problem, the 2x minus y, if you move the 2x to be negative y equals 2x plus 4,
Negative y equals a negative 2x plus 4, right? And then what do you do after that?
you have to get y by itself.
The-
Isn't y already by itself? Or do you do negative?
You divide by negative 1, exactly. So it would be y equals a positive 2x minus 4. Those are our two equations. Is your hand up?
Can I say what it's gonna be?
Oh, you're going to tell me what it's going to be?
Yeah.
Nah, I think I'm going to give everybody a minute to finish. Yes, Allie?
It's okay for the first one because you got like a negative y.
You got a negative what?
Y.
For the first one?
Yeah, I have negative y equals 1 over 2x minus 3.
You can't have a negative y. So now what you have to do is either multiply everything by negative 1 or divide by negative 1. So you want the y to be positive. You can't have a negative y. Are we ready to graph this now? Okay, Tom, tell me, how am I going to start graphing the first one?
You're going to put the y coordinate at 2,
Mm-hmm.
and then you're gonna go up or go down 1 and go across 2 to
Good. So we're going to start off by going down 1 to the right 2 or to the left 2?
the left.
Oh, be careful.
The right.
To the right. Since my 1 is negative, that's why I'm going down. But that 2 in the denominator, isn't that positive? So my run is negative, but I'm sorry, my rise is negative. That's why I'm going down. But my run is positive, so we got to go to the right. So you're down 1 to the right 2. Did I lose anybody with that? Down 1 to the right 2. Now to get the other half of the line, instead of going down 1 to the right 2, what do I have to do? Go up 1. Which way? Up 1. So we went down 1, right 2. Now we're going to go up 1, left 2. Thank you, Brenda. Up 1, left 2. And there's my line. Okay, so now what am I going to do? Now I have to graph my other line. So when I graph my other line, where am I starting now? Who wants to walk me through this? Jake, thanks.
You're going to start at -4,
Okay.
and then you're going to go up 2 into the right 1.
Good. Our slope here is 2, which is really 2 over 1. So that means my rise is positive 2 and my run is positive 1. So up 2 to the right 1. And keep going. Up 2 to the right 1. up to the right one, up to the right one. Okay, these lines are definitely not parallel. Do you agree? They're definitely not parallel. They do intersect. I don't know if you realize this because you don't have a protractor. But does anybody know at what angle these lines are intersecting if you look at it? Allie? I can't hear you. Yeah, like how many degrees when they intersect? What kind of angle are they making? If you can just eyeball it, if you're taking a guess. 90, you got it. These lines intersect at 90 degrees, which means the lines are what to each other? Perpendicular. There you go. All right, so do these lines intersect? We're going to write yes, they are perpendicular. Okay, now we have to make a connection between their slopes. So one slope was -1/2, and the other slope was 2/1. What's the relationship between -1/2 and 2/1, Rach?
Stuff is like the opposite and flip-flop.
Good, opposite and flip. Does anybody know what we call when a fraction is flipped? It starts with an R. Juliet? Reciprocal. So the slopes are opposite reciprocals. So an example of opposite reciprocals is 2/3 and -3/2 are opposite reciprocals.
You do y equals -1/2x plus 2 again on the...
Show you how I got it? Sure.
Like on the graph.
Oh, you want me to graph it?
Yeah, because I was confused.
Sure. What's up, Brenda?
So like, without the negative, is it not opposite anymore?
Without the negative, they are not opposite. Exactly. Okay, so to show you how I graph that first line, we go, this is y equals mx plus b. We start with our y-intercept. What's our y-intercept? Plus 2. Where am I starting that?
On the y-axis.
Good. Up 2 on the y, right there. And then my slope is -1/2, which that represents my rise over my run. So my rise is -1. So instead of going up 1 to start, I have to go down 1. But now my run is positive. So which way is positive? To the right or to the left? So you're down 1 to the right 2. And then you go again, down 1 to the right 2. Now to get the other half of the line, instead of down 1 to the right 2, what am I going to do? Up 1 to the left 2. You got it. Better? Okay, so let's fill this out. Two lines are perpendicular if they intersect at right angles. The slopes of these lines are opposite reciprocals. And the symbol for perpendicular we are all very aware of at this point is an upside down T. Are we all done copying this? Can we move on to the special cases? Okay, special cases. So we want to plot the points -4, 3, and 5, 3. Before I plot these points, I want you to tell me if you notice anything about these 2 points. Mia?
They have the same y coordinate.
They have the same y coordinate. Do you think that's going to have an effect on how the line looks? Absolutely, it's going to have an effect on how the line looks. So let's plot these points. So remember, plotting a point is very different than graphing slope. When you plot a point, it's always x first, then y, right? It's xy. So what do? We do horizontal, then up or down. So we're going -4 on the x, 1, 2, 3, 4, then up 3, 1, 2, 3. You walk to the tree before you climb up it. So or some teachers say you crawl before you walk. Nobody likes that? All right, fine. All right, so that's the first point. How am I going to plot the point 5, 3? What am I going to do? To the right 5 and then up 3. And now we want to draw a line connecting these points. What kind of line is this? Well, all lines are straight. More specifically. Want to try again, Bryce? Starts with an H. Thomas? Horizontal. This is a horizontal line. Okay, I want to talk about the slope of this line. So if we're going to find the slope, we know the slope is rise over run. Well, to get from the first point to the second point, am I rising at all? So what is that rise? Ollie? 0. And then we're running 1, 2, 3, 4, 5, 6, 7, 8, 9. We're running 9. Okay. I always like to compare slope in terms of skiing. If you were skiing on this line, how much fun would you be having? None. You'd be having 0 fun, right? This would not be fun to ski on this line. Why would it not be fun to ski on the line? Because you'd be dragging yourself the whole time because there's 0 slope, right? All right, that is the purpose of this. All right, would you be alive? Would you be safe?
Yeah.
You would definitely be safe. You'd definitely be alive. So basically, if the slope is 0, 0 divided by anything is 0, that's okay. So if you have 0 over a number, we say that's okay. You're allowed to have 0 in the numerator. You'll still be alive. You're just not going to have any fun. So when you have a 0 slope, it is going to represent a horizontal line. Okay, now we want to find an equation of this line. Well, when I ask for an equation of the line, aren't I looking for y equals mx plus b? And I need a number for m, and I need a number for b. I need a number for m, and I need a number for b. Jake?
Y equals 3.
Yep, you're a step ahead of me. Yep, you're absolutely right. So do we agree that this is going, that our m is 0? So y equals 0x, and then b is our y-intercept. Look on your graph. What is your y-intercept here? 3. Your y-intercept is 3. Where else did we see that 3? And both our y coordinates. Okay, that's very telling. So if I simplify this, 0 times anything is what? 0. So my equation is 0 plus 3. Well, what is that? 3. So the equation of this line is y is equal to 3. This is a special case. Are you ready to write this out? Let's write it out. Y equals a number will be the equation of a horizontal line. Okay, so that's the one special case. So most lines are y equals mx plus b, right? So now if we just have y equals a number, not y equals mx plus b, it's going to be a horizontal line at whatever that number is. So this was y equals 3. We're going to have a horizontal line right at y equals 3. All right, so we talked about a horizontal line. Guess what we're going to talk about now? Katie? A vertical line. All right, so let's plot these 2 points. What do we realize about 5, 2 and 5, negative 4? Allie? They're not the same points. Oh, same x. Good. They have the same x. So let's plot these points. We're going 5 up 2 and then over 5 down 4. I'll just freehand it. And there is our vertical line. Where is our vertical line? At what point? Or what x coordinate does it keep going through? 5. Okay, now let's talk about this. Let's find the slope of this line. Now, our slope is always found by rise over run. Well, now to rise, I'm going to go up 1, 2, 3, 4, 5, 6. Am I running left or right at all? No, so that's 0. Are we ever allowed to have a 0 in the denominator? No. What do we say when the 0's in the denominator? The fraction is what? Thomas? Undefined. All right, so let's think about this. If you were skiing down this line, what would happen? You would die for sure. You would 100% die. All right, so there's no chance of survival. So this is not a 0 slope. What happens when there's a 0 slope? Okay? You don't move when there's a 0 slope. This is not a 0 slope. This is either an undefined slope or a no slope, meaning there's no chance of survival. There's nothing going on here except that you're going to die. So m is equal to an undefined slope or 0. Oh, not 0, sorry, or no slope. So as you learned in Algebra 1, 0 over a number is okay, but a number over 0? No way. You cannot do that.
Have you ever seen Slope Man?
I think somebody in one of my geometry classes made me pull it up because they're like middle school teacher showed them. It was painful to watch, to be honest with you.
Awesome.
Okay, so now we want to find the equation of this line. This is a special case. Because there's no chance of survival on this vertical line, it's not going to be y equals mx plus b. It's not even going to be y equals. Jake, you think you know? It's going to be, yep, x equals the constant x coordinate. So what is the constant x coordinate here? 5. Okay, so how do I remember that y equals a horizontal line, x equals a vertical line? If you turn the y upside down, doesn't it look like an H a little bit? And if you cut the x in half that way, doesn't it look like a V? So x equals a number is a vertical line, y equals a number is a horizontal line. So x equals a number is a vertical line.
4 and then y with the numbers horizontal line.
Got it. Allie.
So everything on top is 0 from the bottom.
It's going to be undefined, the slope.
Every time it's on the top, it's just y equals.
A horizontal line, yep. So, yeah, you got it. All right, finding x and y intercepts. Okay, just think about this. Don't draw this because I'm going to erase it. But when I have a line, do we agree this green point is the x-intercept and the pink point is the y-intercept? So when we have, let's look at this. When we have the x-intercept and the y-intercept, all right, when we have the x-intercept, isn't that the point right here, 2, 0? And when we have the y-intercept, isn't that the point 0, 2? Do we agree? So the x-intercept is 2, 0. The y-intercept is 0, 2. So when you have an x-intercept, guess what y is always going to be? No, the y coordinate for the x-intercept, the y coordinate will always be 0. And for the y-intercept, the x coordinate will always be 0. Do you guys need me to repeat that? Okay. When you have an x-intercept, right? Do you see the green dot? That's an x-intercept. That's the point 2, 0. The y coordinate, the y part of the point, will always be 0. And for the x-intercept, I'm sorry, the y-intercept, see that point 0, 2? The x coordinate will always be 0. So when you cross the x-axis, y is always 0. When you cross the y-axis, x is always 0. Makes sense, right? Okay, so what do I want you to do when we're finding the x and y intercepts?
What if for like 2, 0, you go up and then the x and y change? Like, you go up according to the slope?
Yeah, it's not always going to be the same point. So let's say I'm up 1 over 3. Down 1 over, down 1, 2, 3, down 1 over 3. Like, it's not going to always be the same point. I just did that. Do you see? Like, it's not always going to be the same number. So this is 0, 2, and this is like, I don't know, negative something 0. It's not the same. Okay, so let's fill this in. To find the x-intercept, we're going to let y equal what? What did we say? Let y equal 0. To find the y-intercept, what are we going to let? X equals 0. Okay, so number 7, find the intercepts. So we're going to first we're going to find the x-intercept. Let y equal 0. So what am I going to do? I'm going to take my equation, negative 4y minus 12x equals 32. And now I'm going to substitute in 0 for y. So negative 4 times 0 minus 12x equals 32. 0 minus 12x equals 32. So we're at negative 12x equals 32. And now we divide by negative 12. Can I simplify 32 over 12? We sure can. Divide by 4. And we are left with 8 over negative 3. But the x-intercept is not a line. What is the x-intercept? Allie? Say it one more time. No, the x-intercept is not a line at all. What is the x-intercept? Not a line. Not slope. Here's the x-intercept right here. What is the x-intercept? It's a point. It's a point, right? The x-intercept is a point. How do we write a point? How do we write a point? Tom?
X, comma, Y.
You got it. So the x-intercept is going to be the point 8/3, comma, what's the y? 0. 8/3, comma, 0. All right, now we got to find the y-intercept. We're going to let x equal 0. So same thing, we're going to take our equation, negative 4y minus 12x equals 32, and now we're going to let x equal 0. So negative 4y minus 12 times 0 equals 32. Negative 4y minus 0 equals 32. Negative 4y equals 32, so y will equal negative 8. But is the y-intercept a line? No. What is the y-intercept? What is the y-intercept of a graph? Somebody besides Tom. What is the y-intercept of the graph, of a graph?
0,
Good. It is a point. The y-intercept is a point. So what is our point? Our point is going to be 0, comma, negative 8. That is our y-intercept. All right, we are going to stop here. We will finish up this lesson tomorrow. Say it one more time. There's no whole thing. So you have the x-intercept by itself, and you have the y-intercept by itself. It's two separate answers. No, your homework will be given to you tomorrow. It'll be a worksheet. Yes. Allie.